Hey guys, today we're going to take a look at the picoCTF problem, Clutter Overflow. The description reads, clutter everywhere and not a byte to use. We get both the source code and the executable to run, and I've gone ahead and downloaded those in the directory right here. If we try running the program, we get this neat little ASCII art image that looks like a cozy little living room with a small little bedroom here in the back. It looks like a really nice place to curl up and read a book. But the prompt asks us, what do we see? And let's just give it something real quick to test the waters. I see a cozy little space. So I'm going to say cozy. And it seems to tell us that the value of code is equal to 0 when it should be equal to dead beef, as in it's not currently equal to dead beef. So let's look at the source code to see what exactly is going on. Okay, starting here at the top, we see two preprocessor macros for size and goal. These might come in handy later. We do see where the neat little ASCII art image comes from in the header. As we can see here, the main function is actually not too long. The very first thing that it does is set the value of code equal to 0. It then allocates a stack-based buffer of size 100 on the stack. It prints out our header and then asks us what we see. It then asks for user input and places the result into clutter via this call to gets, which is kind of risky. We'll come back to that. And then the program kind of goes two different paths. If code is equal to goal, so this value that's originally set to 0 is equal to goal, which is dead beef from our preprocessor macro up here, then the program will print out our flag via the system call. Well, this call to system, rather. And otherwise, it's going to print out what the value of code is and what the value of goal is. But if the program is setting the value of code equal to 0 here, right, when it first runs, how are we ever going to get it equal to dead beef? Well, if we look at where this is allocated, it's right above on the stack where our buffer is, our clutter buffer. And via this call to gets, it will not do any sort of user input validation, as in it won't do any bound check. We can feed it more data than 100 bytes. And what will happen is it will continue to write up the stack and overwrite any values that are above it. So in this case, since we can write over the bounds of this buffer, we can then control the value of code. So let's test this out by running the challenge again. And this time, let's just give it a bunch of A's. And what I would expect to see is that the value of code is no longer 0. So let's try this out. And by a bunch of A's, we just have to be over 100. So let's hope that this is somewhere in there. Okay, and indeed, we do see that we get a bunch of 6 ones. And these are the hexadecimal representations of the ASCII A, so 6-1. So this makes sense. So what has happened here is we have written beyond the bounds of our stack and overwritten the value of code. So now that we can control the value of code and we know what we want the value to be, dead beef, the remainder of this challenge is to figure out at what offset in our buffer to place dead beef at. So we could do this manually by examining the stack offsets, but let's be lazy and approach the problem in a more repeatable way using pwnTool's cyclic pattern methods. All right, so the very first thing that we're going to do is start an interactive Python session. And this will just help us to remember all of the different API interfaces available to us with pwnTools. So let's go ahead and import that. And let's declare our executable. And we see that it ran checksec for us. Now let's actually go ahead and start our process. So we can say something like IO is equal to process. And then because we don't need any arguments, we can just give it the path to the program. Okay, and now we need to generate our cyclic pattern. And this is going to tell us at what offset we need to place dead beef. So we'll say pattern is equal to cyclic, and then the length is going to be, it just really needs to be over 100, but let's go with like 500 or so. And we want to give it the same type of bytes as the program, so we'll say n equals exe.bytes. Okay, and so here is our cyclic pattern here, so it's quite long. And now we actually want to send this to our program. So we'll say io.sendLine after And the program prompts us for the input right after it asks, what do you see? So we'll send it after we get that. And we know that we want to send our pattern here. All right. And so now we want to get the output that is immediately following this. So we're going to say code is equal to our IO and receive line. And we know that it should contain, we'll cast this as a string here. We know that it's going to contain the code is equal to blank, right? We know that because it's not going to be equal to deadbeef, that this is the branch of the program that it's going to take. Okay, and so now if we print out that, we see that our code value is no longer 0, but it's equal to this value right here, which is part of our, or should be part of our cyclic pattern. So let's go ahead and try and convert that. So we'll say code is equal to, we need to get this part, so we'll say code.partition, and we want to partition our code equal to 0x, and we want the second part of that, so we're just trying to get the 6.2, 6.1, so on and so forth. That's what we're trying to get. So that's what we should have here. Okay, and now we want to convert this to an integer. So we can say int code, and we know that the base is going to be 16 because this is in hex. Cool. So there, if we convert it back, we see that it is indeed the same. And so now we can find the offset by using the PwnTools sleek function cyclic find. So cyclic find. And we want to find where code exists inside of our cyclic pattern. Cool. And so the offset occurs at 264. All right. So now that we know the offset, we just need to place deadbeef there. So we can do that by saying something like payload is equal to fit. And then we can say our offset, or at our offset rather, we want to place the value dead beef, if I can spell that correctly. Cool. And then so if we look at our payload right now, we should have a bunch of gibberish followed by dead beef. And so now if we send this to the program, we should get our answer. So let's go ahead and restart our process. And now we just want to send this to the program. So we'll say send line after, what do you see? And then we'll send our payload. And now let's just go ahead and just step through it by printing out each of the new lines that we receive. So we get a new line, and then we see that the program did say code is equal to deadbeef. How did that happen? Take a flag for your troubles, and here's the flag. So picoCTF, controlled clutter in my buffer. And if we were to take that and place that into the picoCTF gem, we would get our points. So thanks for following along. I hope that you learned something today. I hope this was productive, and I'll see you next time. Thanks.